Buffers maintain constant pH. Here's how they work. Let's get a little background first on what changes pH. So here I have a beaker of water. What's going to change the pH? So if I add HCl, which is an acid, and I add it to this solution, here's what's going to happen. The HCl is going to break up into H, hydrogen ions, and chloride ions. So the pH decreases. Okay, another way to change the pH, if we have a beaker of water, is to add something like sodium hydroxide. Sodium hydroxide is the base because of that hydroxide. So when we put sodium hydroxide into water, it dissociates into sodium ions and hydroxide ions. So the pH goes up because of that hydroxide ion. So in order for a buffer to work and maintain constant pH, it has to have something that's going to react with this hydrogen ion so that it cannot be free. And it's got to have something that's going to react with this hydroxide ion so it can't be free. So there, we would need a mixture of something that will react with hydrogen. You could say absorb the hydrogen. And at the same time, it would also be able to absorb hydroxide if we added that. So a buffer is usually made of Buffers are usually made of a weak acid and its salt. Remember what a weak acid is? A weak acid is something unlike HCl. When you put HCl into water, it completely comes apart into H plus and Cl minus. But if I put something like acetic acid into water, it mostly stays together as molecules. There's going to be a little bit of hydrogen ions and a little bit of acetate, but not much. Now, what do we mean by its salt? What is the salt of a weak acid? Well, what's the salt of a strong acid? The salt of HCl would be NaCl. So the salt of this weak acid would be something like NaC2H3O2, sodium acetate. When you put that in water, it dissociates like any salt that's soluble, and it dissolves as ions. So if we put these two substances into the water, such as acetic acid and sodium acetate, here's what's going to happen. We're going to have sodium ions, we're going to have acetate ions, because that's how sodium acetate dissolves, because it's a salt that's soluble. Soluble salts dissolve as ions. And then we're going to have the molecules of acetic acid. Okay? So what's going to happen if we add HCl? So we add HCl, the H and the Cl come apart, and the H is going to look for something to react with. It's got to react with something in order to be absorbed. If the hydrogen ions are allowed to go free as free ions, they will lower the pH. But here's what happens. The hydrogen ions react with the acetate ions and form acetic acid. And because the H plus is not free, it does not lower the pH. Okay? So now we've absorbed the we've absorbed the hydrogen ions. Remember, when we add HCl, it's really the same as just adding H plus. All right, let's get rid of HCl. And what happens if we added a base like sodium hydroxide? What does that mean? It means we're really adding hydroxide ions. So if we put this into our solution, if the hydroxide ions are allowed to be free, they're going to raise the pH. But is there something that will react with the hydroxide ions? And you can see that it's right here. It's the acetic acid. Because what hydroxide really wants is that hydrogen. And it will take the hydrogen away from the acetate. And what it's going to form is H2O plus acetate ions. So hydroxide is not free to raise pH. So to be a buffer, you've got to have a weak acid and its salt. You could have something like this. Here's a weak acid, hydrofluoric acid. Here's the salt of a weak acid. Those would be a buffer. Here's something that would not be a buffer. HCl and KCl. That's because this is a strong acid. There's other things. We could have a weak base like ammonia and the salt of the weak base, NH4Cl. That would be a buffer. Here's another buffer. Here's a weak acid, HClO. That's called hypochlorous acid. And any positive ions, so we could take lithium or sodium or potassium. And there's our salt, lithium hypochlorite. So all of these right here would be good buffers. They would have a particle that would react with added hydrogen or added hydroxide. Buffers maintain a constant pH by having something that will absorb hydrogen ions, and they must also have something that absorbs hydroxide ions.